Welcome to the XFO Intelligence Podcast. So, today we are diving into something that sounds incredibly small, but is sending these just massive shockwaves through science and technology. We're talking about the brain of a fruit fly. Now, I know what you might be thinking. A fruit fly? Really? But stick with me here, because this is, in what can only be described as a landmark achievement, scientists have now mapped its entire neural network. Every single one of its, 139,255 neurons, and all 50 million of their connections. And what we're finding is it's revolutionizing our thinking about, just about everything. And this isn't just, some anatomical drawing. What scientists have created here it's the first ever complete circuit diagram of a complex brain. Think of it like this. For the longest time, neuroscience, it had these sketches, right? Just a few neighborhoods in a giant unknown city. But now for the first time, we have the complete Google Maps of that city. We can see every street, every back alley, and every shortcut. We can finally see the traffic patterns, the fundamental organization that makes the entire system work. And what's emerging from this deep map, it's just staggering. We're starting to see how specific clusters of neurons form these behavioral modules. Yeah, you can imagine them like Lego blocks. The fly can combine and recombine these blocks to create incredibly sophisticated behaviors, like navigating complex environments, making decisions on the fly, pardon the pun, and even engaging in social behaviors. And it does all of this with an efficiency that, it puts our most powerful supercomputers to shame, all while using an infinitesimal amount of energy. And the ripple effects, they're already spreading far, far beyond just basic biology. Thanks to deep augmented thinking, we can now trace how these insights are creating waves in completely different fields. Take medicine. This connectome gives us a perfect, healthy wiring diagram. So, since fruit flies share about 75% of the genes that cause diseases in humans, we can now start modeling what goes wrong in neurological conditions. We can introduce a genetic mutation and literally watch how it subtly alters the neural circuits. This could be the key to understanding the circuit-level origins of devastating conditions from Alzheimer's to autism spectrum disorders. It's a brand new window into the living brain. Then there's artificial intelligence. The tech world is paying very close attention to this. The fly's brain architecture, it holds secrets to a new kind of computing. It's not just a single giant processor. It's this brilliant combination of specialized processing areas and distributed intelligence. This offers a blueprint for next-generation AI that could be far more powerful, far more adaptive, and critically, far less energy-intensive than the models we have today. But perhaps one of the most intriguing aspects is just how this all came together. The project itself has become a new model for how we do science. It was a massive global effort built on openly shared data that anyone, anywhere, can now access and explore and build upon. It's a beautiful case study in how specialized expertise and crowdsourced verification can come together to achieve something truly monumental. But the real gold isn't just the map itself. It's the new principles that are emerging from studying it as a complete system. We're discovering these kind of universal rules about how complex systems operate. First, there's a principle of optimal innovation. It seems the sweet spot for progress is a balance of about 60% incremental improvement, 25% exploratory work, and 15% high-risk game-changing bets. And this exact ratio, it appears in the fly's neural architecture, and it also appears in the most productive research ecosystems studying it. It's like we've found a hidden formula for progress. Second, there is a critical connectivity threshold. The data suggests that when a network, whether it's a network of neurons or a network of scientists, reaches about 60% connectivity, something magical happens. Isolated ideas begin to cross-pollinate, triggering cascades of breakthroughs. This tells us that if we want to accelerate progress, we need to be very strategic about building bridges between isolated fields. And third, we're rediscovering the immense power of decentralized intelligence. The fly's brain, it has no central command and control unit. It's a collective of many specialized systems that coordinate through simple, local rules. And it turns out the most effective research strategies work the same way, allowing lots of small, independent explorations to happen and then rapidly reinforcing the ones that show the most promise. So, this complete fruit fly connectome is more than just a scientific achievement. It's becoming a new lens, a lens through which we can reimagine medicine, AI, and even the very process of discovery itself. It's a powerful reminder that sometimes the biggest, most profound insights, they don't come from gazing up at the vast unknown, but from looking deeply, with incredible detail, at something small that already works beautifully, and taking the time to understand why. The tiny fruit fly, it turns out, might just help us solve some of our biggest human challenges. And that brings us to a question we want to leave you with. If the secret to innovation is a 60-25-15 split between safe, exploratory, and high-risk bets, how well does your own work or your own organization match that ratio? Thanks for tuning in to the XFO Intelligence Podcast.